Sir, this is Karan, and I'll be doing the first question of homework 4. In first question, we have been given an graph of distribution on a density function of x and the values of y as some values of x, and we need to find a distributed function of y and a density function of y. So from this particular distributed function, density function of x, we get a distributed function from 0 to 1 of x as this something like this. This is an arbitrary, it's just an arbitrary figure, and values of y is given as shown here. So seeing this, we can see that we have values of y between -1 and 1. Even for this, it will be between 0 -1 and 0. So we have the total value of y but somewhere between -1 and 1. So so it will the distributed function for of y for less than -1 would be 0, and for greater than 1 would be 1. Now at y is equal to -1, we have probability of y is equal probability at y is equal to -1, that y is equal to -1 would be something that would be same as probability at x of x greater than 2. So for this we can we can rewrite this as 1 minus distribute function f of x at 2 at y is equal to so now at so yes, so now for value of y 0 to 1 -1 to 0, we have values of x we have yeah for value for y between -1 and 0, we have y is equal to minus x plus 1. So the density function is given as the f of y is given as f of x upon on the modulus derivation of g of x. Now that is equal to f of x 1 upon -1. This should be my modulus. This should be modulus. So that becomes plus f of x 1 minus y. So and as at y is equal to 0, we have uh, at y is equal to 0, the probability at y is equal to 0 is same as probability of 0 to probability of x between 0 to 1, and that can be written as fx1 minus fx0. And at y is equal to 1, we can rewrite it as the probability at y is equal to 1 can be written as probability of x less than 0. That's equal to fx of 0. So actually taking these values, we can rewrite the density function of fy the density function of y as at 1 it would be 1 at 1. Let's check at 1. At 1 it will actually at -1 it would be 1 minus fx of 2, and the unit impulse function and the unit impulse function at between 0 to between -1 and 0, it would be a continuous function of fx of 1 minus y. At 0 it would be a impulse function of fx1 minus fx0, and at 1 it would be a impulse function of fx0. So we have fy of y. Now if we take now fy now distribution function of fy would be derivation of these terms. So after derivating, we get these values, that is for y less than -1 we have 0, for y greater than and for y greater than 1, and we have that is always will be 1, and between 0 to 1 it would be 1 minus f of fx of 0, and from -1 to 0 it would be 1 minus we have a so if we derive we have derived the value of fy of y at between -1 to 0, that is the integration of fy of y from minus infinity to infinity. So the graph is something like this. Thank you.